So now we get to talk about the ever important subject of the moon. Now, as you know, one of the things we need to talk about is lunar phases. Like we have a full moon, we have a new moon, we have the crescents, we have the quarters. But you probably already know that the moon orbits the Earth, right? The moon goes around the Earth, but the moon also spins on its axis of rotation. So actually, those are in sync. So about every, you could say 28 days, but actually it's a day and a half more than 28 days. Every 29 and a half days, Earth days, the moon orbits the Earth and rotates once on its axis of rotation. And in a minute, I'm going to show you what is the consequence of that synchronous rotation. It rotates and orbits the same amount of time. When the moon orbits the Earth, okay, the Earth is not in the center of its orbit. Kind of like the sun is not in the center of Earth's orbit. It's offset. So we have a closest location called perigee, when the moon is closest to the Earth, and then we have when the moon is farthest from the Earth, we call that apogee. So actually, here's a figure, I believe from your textbook, that shows you perigee and apogee. So let's see, looks like perigee. So this is the moon orbiting the Earth, okay, and the Earth would be in the center here. So this is perigee, perigee, and this is apogee. And if you're like, those names sound familiar to something I've just listened to or read in the textbook, actually there's perihelion, which is when the Earth is closest to the sun, and aphelion, when the Earth is farthest from the sun. So we have perigee and apogee, kind of similar to that. So when we have a full moon at perigee, okay, full moon, if the full moon is here, and we'll talk about lunar phases, okay, we call that, dun dun dun, a supermoon. And actually, fall 2015, we have back-to-back supermoons. I think it's the September full moon and the October full moon are both occurring at perigee, or within a few hours of perigee. Okay, so that's exciting. So the only reason we see the moon is because light from the sun is striking the moon, okay, and we see that, okay. So I kind of like this little figure here because, of course, we have the Earth in the center, and the moon goes counterclockwise, just kind of like you see from this arrow. It's all about counterclockwise in our solar system if we're looking down at the north axis of rotation. Okay, so, but anyway, we would call this, so just go ahead and kind of give you a heads up how this works, because you're going to see it on the next figure. We would call this a full moon. I'll go clear over here. Can you see why that is? We see the half of the moon that's illuminated. Actually, here is a quarter moon, and here is a quarter moon. Does that make sense? Okay, they're quarter moons because the part of the moon that we see, okay, looks like that. These actually, let me do one more right here. This is a new moon. Does that make sense? Because you figure the sun is over here, the illuminated part is over here, the part of the moon that we can see is here, okay, and actually it's all dark. So that is what we call a new moon. So this figure just kind of reinforces that, why we see phases of the moon that we see. So for instance, in this case, this girl, this young lady, is the Earth, okay, and she is extending the moon in her hand here, and so the sun is over in this direction. So for instance, as she holds her hand there, I think it's a pretty good figure, as she holds her hand there, can you see where when it comes time for the side of the moon that she sees, it's all not illuminated. So this is a new moon, okay, and this moon will rise with the sun and set with the sun. So in general, that would be a 6 a.m. rise and a 6 p.m. set. Okay, and then actually the moon is going to go over here next, Okay, it's going to be what we call in a crescent stage. It's getting larger, so it's a waxing crescent, and you can see that instead of rising at 6, it's going to rise at 9 a.m. and set at 9 p.m. So about 12 hours for the moon to be up. Then going on to the next phase, at this location, actually you can see where actually from the young lady's standpoint, she sees a quarter moon. She sees this moon, it's actually what we call first quarter. So one of the things, I like this figure because can you see where as you go from this one to this one, from a waxing crescent to a first quarter, that actually it is illuminating, it's what we say waxing from the right back to the left. Okay, so from the right back to the left, it's getting more illuminated. So then over here, kind of move this up a little bit. Over here, you see when the moon is here, not quite behind the young lady, actually what she sees is even more a portion of the moon. We call that a gibbous if it's more than a quarter, and it's still getting larger, so we call it waxing. And it looks like you can see that this actually rises at must be 3 p.m. and sets at 3 a.m. So it's rising later and later. Then finally we see the moon behind her. So here's the moon behind her. So behind her, remember this is the sun, so the sun is shining on the moon, so actually she sees a full circle. So this actually is the full moon phase. Okay? Right here, full moon. Okay, it generally will rise about 6 p.m. when the sun is setting, and set when the sun is rising. Okay, and it kind of makes sense because it is opposite the sun. Then the moon continues to orbit the earth. It goes over here. Now at this point, at this point it is actually getting smaller, less illuminated from left to right. So if I go, from right to left, from right to left. Okay, now the process that is continuing from right to left actually is the undoing of illumination. It's the unillumination. Okay, then the moon will scoot around here, and it will be at this position where she sees a quarter. This actually is, I call it the last quarter or third quarter. Okay, and then it will continue to what we call wane. Here we have a waning crescent. So after third quarter, before new moon, we see just a crescent. Notice that here they are rising and setting later and later. So a third quarter moon rises at midnight, sets about noon. Waning crescent rises about 3 a.m. and sets about 3 p.m. So you can definitely see the moon during the day. One other thing that's on the slide is the term terminator. I'll be back now. The term terminator actually just means where, let's pick this this first quarter. The terminator is where you see the lit side separated from the non-lit side. Right there is the terminator. And actually that's of interest because if you were looking through a telescope, that's the cool place to look. So here we have, I have a slide that has the phases of the moon. So it starts out as a new moon, okay? And that is when the moon is what? Between the earth and the sun, right? Then it scoots on around. We have a waxing crescent after that, first quarter, waxing gibbous, full moon. And then it's getting less. So we have a waning gibbous, last quarter, third quarter, a waning crescent, and then we have the new moon again. Okay. So the term waxing means that more and more of it's getting illuminated. The term waning means that less is getting illuminated. Now I can see that actually when I pulled these over, these aren't matching up, right? So for instance, let's pick red. The waxing crescent is there, the first quarter is there, the waxing gibbous, the full, the waning gibbous, the last quarter, and the waning crescent. They kind of got screwed up as I came over. So, if you've heard of this concept of the dark side of the moon, actually the dark side of the moon I'm not quite so sure about, but I am very sure about something called the far side of the moon. Okay, so the far side of the moon is because of this. Remember I said that every 29.5 days the moon rotates once on its axis, okay, and it rotates once and it also orbits the Earth. So that's what we call synchronous rotation. So because of its synchronous rotation, it's like a dancer that will never turn his or her back to their partner. So it always faces, the same face of the moon is always directed towards the Earth. And I like this down here, okay, kind of showing you. This would be a situation where this gal is going to, if she's the moon, in this case, she is going to go ahead and orbit the Earth, okay, but she is not going to spin. So she's orbiting, call this A, B, C, and D. In this case, she's not spinning. She's just orbiting, right? And that's not what our moon does. It actually completes one rotation on its axis, spinning on its axis, by the same time it orbits the Earth once. So this is synchronous rotation, where the same amount of time, now we have the gal who not only is she moving about the, not only is she representing the moon that is orbiting the Earth, but she's also spinning on an axis of rotation. So notice that here from here to here, she has done 1/4 spin. Okay, from here to here, she's done 1/2 a spin from what she started. From here to here, she's done 3/4 of a spin. And from here to here, she's done 1 full spin. Notice that she has also then completed 1 orbit about the Earth. So that's synchronous rotation. Now look to see what side of that young lady you see. You always see her front. You always see her front. You always see the same side because she's spinning on an axis the same rate she's orbiting. Okay, so that's the consequence. So what we say then, put in other words, her back, if she is the moon, her back is what we call the far side. Not the comic strip, but that's what we call the far side of the moon. It's the side of the moon that we don't see. And not so surprising, and we're going to talk about the formation of the moon and the formation of the planets, and but maybe not so surprising that actually when we look at that back side, that far side, it is very much, these are my pock marks, it is more heavily cratered than the front side. Okay, so just to kind of that synchronous rotation, this is the near side of the moon. Okay, and I don't know as many features as I should know maybe. This down here actually is a crater called Tycho. So all the craters are named and all of the other stuff is named. This right here, can you kind of see these dark regions? These are called mare. And then the kind of the light regions are called highlands. And they're kind of old regions because we've been to the moon, we brought back rocks and we analyze them. So all of this is the near side. Compare that, which is what we're used to looking at, to this. Okay, this is the far side of the moon. Was it Apollo 17? I don't know. There was a science fiction movie out there that looked at going to the far side. And of course, there were little alien critters on the far side. But that's the side of the moon that we do not see because of synchronous rotation.